Welcome to this explainer. I am absolutely thrilled you're here today. We are about to embark on a seriously fascinating journey, charting the entire course of artificial intelligence. We're going to trace this incredible technology all the way from the ancient mathematical pursuits of logic straight through to the modern deep learning revolution that is quite literally reshaping our world today. Let's get into it. Okay, let's dive right into this. Because, it's really easy to look around today and think AI just sort of exploded out of nowhere, right? But how do we actually get here? For centuries, philosophers tried to understand human reasoning, but it wasn't until the mid-20th century that we finally moved from abstract philosophical texts into rooms filled with humming 1950s mainframes. This centuries-old quest had finally reached a physical threshold. We actually had machines capable of executing logical procedures automatically, even if those room-sized behemoths had less processing power than a musical greeting card today. Here's our roadmap for today. We'll start with the birth of AI, see how machines learn to adapt, explore the deep learning revolution, look at AI in the real world, check out its impact on labor, and finally wrap up with ethics and governance.
Section 1. The birth of AI, foundations of reason. So before a computer could ever learn, it literally had to be taught how to follow logic. We're talking about bringing George Boole's algebraic logic and Kurt Gödel's mathematical limits right into the physical, tangible realm of computer science. Now, what's really interesting is the timeline of this early AI theory explosion. In the 1930s, Alan Turing made a massive breakthrough with his concept of the universal machine, proving complex logic could actually be executed mechanically. By 1956, researchers like John McCarthy and Marvin Minsky officially coined the term artificial intelligence at the historic Dartmouth Conference. We saw a huge peak in the 60s and 70s with systems designed to mimic human experts, but when the technology overpromised and underdelivered, the funding dried up completely, leading to these long droughts known as the AI winters.
The crucial point here is understanding what exactly they were building back then. It was called symbolic AI, or sometimes you'll hear it called good old-fashioned AI, and it relied entirely on rigid checklists and rules. Programs like the logic theorist could generate these elegant mathematical proofs, and the Mycin system could even assist doctors with medical rules. But there was a major catch. While they were brilliant in highly controlled environments, they lacked basic, real-world common sense. Actually, it's more like they couldn't adapt to the unexpected at all.
Section 2. Machines learn to adapt data and experience.
Now, what's really interesting about this is how we got past those early roadblocks. AI basically had to enter its adolescence. Researchers realized they needed to stop explicitly programming every single rule, and instead they looked to human neuroscience for inspiration. This created a monumental shift, moving from symbolic AI with all its rigid rules directly into machine learning. Instead of hard-coding the answers, machines began improving their performance straight from data and experience. This massive paradigm shift kicked off in the late 1950s when Frank Rosenblatt developed the Perceptron, which was an early artificial neural network inspired directly by the interconnected neurons in our own biological brains. After a bit of a lull in the 70s, this biologically inspired approach just roared back to life in the 1980s. You had researchers like Geoffrey Hinton popularizing the backpropagation algorithm that allowed multi-layered networks to basically adjust themselves by sending errors backward through the system. Today, this whole field relies on three main strategies. There's supervised learning, which uses labeled data, unsupervised learning to find hidden patterns, and reinforcement learning, which trains AI through trial and error rewards, like training a dog, sort of. Combined with massive datasets and modern GPUs, computers fundamentally transformed from rigid calculators into highly adaptive systems.
Section 3. The deep learning revolution, scaling intelligence.
All right, this is where we zoom out and scale up to the multi-layered neural networks that catalyze the deep learning revolution we're all living through right now. A convolutional neural network, or CNN, pulls layered abstractions straight from raw data without any human hand-holding. It's like a giant puzzle. In step 1, the first layer detects simple edges. Step 2 combines those edges into shapes, and by step 3, the deep network can recognize incredibly complex structures, like a human face. It just builds understanding, layer by layer. And, that layered abstraction isn't just for images. It perfectly translates over to text, which brings us to the large language model, or LLM. Models like OpenAI's GPT and Google's BERT train on massive amounts of text using what are called attention mechanisms. This allows the AI to weigh the importance of different words, process incredibly complex syntax, and ultimately generate highly context-aware responses. It's a real game changer.
Let's just pause and really ponder the philosophical weight of this for a second. We literally have machines performing cognitive tasks today, writing coherent essays, designing complex protein structures, stuff we once thought was exclusively, uniquely human. It really is an awe-inspiring continuation of our long history of computation.
Section 4. AI in the real world. Transforming sectors.
So, what does all this actually mean outside the laboratory? Well, we are seeing firsthand exactly how this tech is transforming the societal systems we interact with every single day. Core sectors of our modern economy, healthcare, finance, and education, perfectly illustrate how algorithmic intelligence has stepped out of the lab and into the real world. It's no longer a science experiment, it is active infrastructure.
And this brilliantly illustrates exactly what we're talking about. Take healthcare, for example. Neural networks are currently detecting tumors in radiological images with a sensitivity that actually rivals trained human specialists, and it's drastically speeding up drug discovery. Over in finance, those reinforcement learning strategies we talked about earlier, they are being used to adapt to market fluctuations, detect fraud, and optimize investment portfolios in real time. And in education, adaptive platforms are identifying individual student knowledge gaps to provide personalized mentorship. It just proves that AI is actively augmenting machine-mediated care and instruction globally. Section 5. Automation and labor. The new social order.
Now, when you integrate a technology this profoundly powerful into the real world, you inevitably disrupt the macroeconomic realities of labor. I mean, comparing this to a qualitative shift in human labor on par with the Industrial Revolution, that is for sure not an exaggeration. You can actually trace this industrial shift back to Norbert Wiener's pioneering work in cybernetics, but there is a huge, key difference today. While old industrial tools amplified our physical strength, modern AI automates complex cognitive functions.
We're really facing a dual-edged sort of automation here. On one hand, we're seeing routine and repetitive roles, think inventory management or basic customer service, being displaced by highly efficient automated supply chains and chatbots. But on the other hand, entirely new categories of employment are springing up: data scientists, AI ethicists, and specialized oversight roles. This massive shift is currently amplifying some huge global economic debates over wealth distribution, labor rights, and even whether societies will eventually need a universal basic income as our economic frameworks undergo this radical recalibration. Section 6. Ethics, Governance, and Safety. Stewardship.
As AI continues to scale up, the need for global governance and ethical guardrails becomes absolutely urgently critical. The reality is that neural networks can act kind of like black boxes. Their autonomous pattern recognition creates an opacity that can very easily hide systemic biases. It's a conversation a lot of incredibly smart researchers like Timnit Gebru and Joy Buolamwini are having right now. They've proven that if the training data contains human biases, the AI will just pick those up and dangerously perpetuate structural inequities. We've unfortunately already seen this happen in flawed facial recognition technologies. It's an absolutely crucial thing to keep an eye on.
Fortunately, though, researchers and policymakers are actively building tools to handle this in a very practical way. On the technical side of things, we have explainable AI, which basically forces the machine to show its work so humans can interpret its reasoning. There's also federated learning, which is a privacy-preserving method. And legally, we're seeing frameworks pop up like the European Union's AI Act and UNESCO's ethical recommendations. These frameworks are being built right now to ensure fairness, transparency, and human oversight so that AI functions as a tool for collective problem-solving rather than a source of conflict.
So, I want to leave you with a final, provocative question to think about. The technology has evolved all the way from abstract mathematical logic to complex neural networks that actually mimic human cognition. But the final layer of this evolution? It isn't code, it's us. So, how will we ensure that the artificial intelligence era serves the flourishing of all humanity? It's really up to all of us to be informed stewards of this incredible technology. Thank you so much for joining me for this explainer. Keep learning, and I'll see you next time.